Back. I'm being upstaged because Daisy is going to be presenting from upstage. It's a theatre joke. Daisy is lovely and she will be taking us through a whole bunch of different furniture, including futons and functions and other such things, and I look very much forward to this one. So let's give it up for Daisy.
Kia ora. So before I kick off, I just want to point out this URL over here. For those online, it's in the bottom left of the screen. All of the stuff that I'm referencing in this talk, there's links to that at that URL. So this is a talk about design. Often when we think about design, we think about websites, mobile apps, book covers, and posters. We think about armchairs and shelving systems and calculators and radios. We think of color, shape, material, and texture. But this is also a talk about APIs, the way that one piece of software interacts with another, whether that's by HTTP requests or function calls. And color and shape and so on, they don't really apply to our APIs. So it's tempting to think that design doesn't really have much to offer us. But color and shape are just the tools of a certain kind of design. Design is about making things for people to use. APIs aren't really for computers to interact with each other. They're for people to interact with software by creating more software. Dieter Rams was an influential designer active from the 60s to 80s with Braun, who made far more than just razors back then, as well as a furniture company called Witzer. His armchairs and calculators and such were an inspiration for hardware designers like Apple's Johnny Ive, and it's not hard to come by analysis of his 10 principles for good design applied to websites or iPhone apps. Those 10 principles were a series of short aphorisms that he wrote in the late 70s, kind of like a Zen of Python, but for furniture and stuff. Except, of course, design is more than just furniture and stuff. We're going to explore a couple of different ideas about software and API design, and for each of them, we'll look at how they relate to the 10 principles for good design, and explore what a furniture designer can teach us about APIs. This is a whistle-stop tour. It's a shallow overview of a lot of ideas, with the hope that some of them will prove useful as a starting point for your own exploration. I'm going to cover one of these really quickly, not because it isn't important, it is, but because it can't really be grouped with some of the others, and it's challenging to do it justice in 30 minutes. Good design is environmentally friendly. Should have put my Ventolin. Our industry has an impact on the environment, and with the climate crisis upon us, it's a topic that's as important as ever. Marina McLeod gave an excellent talk at PyCon XI 2019, and she's from New Zealand, she's probably given it here as well, called Environment Variables, and it's linked in the resources. It's a really, really well put together overview of the topic, and I can't recommend it enough. So instead of talking about it here, I'm going to recommend that you watch that talk. I have text that I don't need to read that's on my teleprompter. Good design is innovative. One of the innovations that in our field that I find interesting is the resurgence of static typing. Python gains popularity in part because of its dynamic type system, which was much more expressive and concise than, say, Java. I mean, just look at the number of times you have to tell the language that a string is a string. This resurgence, though, has featured languages like TypeScript, Rust, and Swift, which have new language features like type inference, tag unions, and pattern matching that preserve or even improve on the benefits of static typing, like compile time bug catching and performance, and bring a lot of Python's expressiveness to the statically typed world. What's interesting is that they're innovative, but they're nothing new. When Graydon Hoare first introduced Rust to the world in 2010, he used those exact words, nothing new. Rust has changed a lot since then, but this has largely stayed the same. A lot of its most important features are not invented from whole cloth. Rust documentarian Steve Klabnik elaborates. Programming language research and the software industry live in two separate worlds, and Rust innovates by taking research from years and decades past and bringing it to a more mainstream industry context. You might recall this morning that Chris said something very similar about TypeScript. If you go behind the curtain into community spaces where Rust or TypeScript are built, you'll see lots of researchy mathematical terms. The amount of Wikipedia pages I have had to read to understand the TypeScript bug tracker, oh my goodness. But you'll also see a lot of hard work being poured into the really innovative thing about these languages. People figuring out how to make concepts like this easy to understand and make them accessible for people that don't have and don't want a deep understanding of type theory, so they can best be used and best taken advantage of. Rams said that innovative design always develops in tandem with innovative technology, and that's what's happening here. The innovative technology comes from mathematics, type theory, those research languages, and these languages innovate through language and API design, making that innovative technology useful. The idea that good design is long-lasting feels kind of opposed to the idea of innovation, but it doesn't have to be. Rams criticizes fashionable design, and it's not hard to see the phenomenon of fashion and trends in software. I've done lots of front-end work in the past, but for the past few years, I've been working in Python, and I feel like every time I do something in JavaScript, the tools du jour have changed. I actually had to change the build tool that builds all of this tooling that runs the slides last week because the build tool I used to do this talk last year had been deprecated. This is all JavaScript. But the interesting thing is, if you step back and look at the web itself, that's a long-lasting design. The web was created a few years before I was born, and here I am. I have a career that's largely been building things for it and talking about it in conferences. So why is the web long-lasting? I think it's not just a piece of software. Nobody sits down in front of their next cube and opens up World Wide Web anymore. Protocols and standards, that's what lasts in our industry. Interoperability, so that the next big thing can build on your thing and work with it. HTTP, HTML, JavaScript wouldn't have their ubiquity if they were a proprietary system. They also need to evolve, and the web did so mostly out of luck. When I first started in web development, Internet Explorer 6 had won the browser wars even. Web standards grew stagnant, and then Firefox came along. It was exciting for web users. It had features like tabs, and it let web developers do more by pushing the standards forward. It had the backing of Google because Chrome didn't exist yet. And Firefox from that got not just financial support, but also occasional ad space on the most visited page in the entire web. And we've been less lucky with chat. IRC has been stagnant for a while. It has everything you need if you still live in a VT100. Meanwhile, proprietary chat platforms have been adding inline formatting and emoji reactions. And I mean, not long ago, it used to be that if you posted non-ASCII text in an IRC channel, you'd get yelled at because other people's clients didn't support Unicode, and that was your fault somehow. And there's a whole other talk you could write on this, so I'm just going to drop my hot take and move on. Free software is largely dead in some ways, and IRC is a pretty good illustration of why. The free software movement has gotten stuck navel-gazing, making deeply disturbing jokes, and not getting why half the population is put off by those jokes. Meanwhile, on the other side of the fence, you could exchange a huge bucket of money and your soul for a shiny box that you're not allowed to tinker with, but the Wi-Fi works properly on day one. I know Wi-Fi does work a bit better on Linux now than it used to, but there's some other things that break. And the other side of the fence, they have more fashionable designs. Slack is already being supplanted outside the business realm by Discord. Soon we'll have another proprietary walled garden. None of them will work together, certainly not natively. Certainly not without lots of sort of one-person GitHub projects that are sometimes maintained. So, yeah, there are market forces working against long-lasting software. Lock-in and disposability create revenue, and that revenue pays many of our paychecks. So there's two keys here to making long-lasting technology. That was the end of the hot take. One is openness, interoperability, all of those sorts of things, and the other is continuing to evolve and progress and, yes, innovate on top of that open foundation. Next, I want to talk about learnability. Rams could have been talking about code here. Self-explanatory is reminiscent of self-documenting code, which is such a common goal, so frequently missed that it's kind of a running joke. Unironically, calling your code self-documenting is usually a bad sign. Learnability is also a critical part of what makes an API useful. When we're writing an API, we know how it works because, well, we're writing it. But we can't beam that knowledge into our users' heads. And we also can't do that for the domain knowledge around what your API does. If I'm using a library to read Excel files, it's because I don't want to deal with the intricacies of Excel's file format. Nor can we do that for the context we worked in. When I asked penetration tester and speaker Lily Ryan what she thought made an API useful, she immediately mentioned learnability. APIs harm their own usefulness by being hard to navigate, offering too much, or not enough, or by not being set up in a way that makes intuitive sense. And it kind of makes sense that you wouldn't want a pen tester to understand your API, but you want everyone else to. And I guess if Lily understands your API before the bad guys do, that's probably a good thing. One place you can combat this is documentation. In his talk, What Nobody Tells You About Documentation, Daniela Procada divides the docs you provide with your API into 4 types: tutorials, how-to guides, discussions, and reference. Tutorials are the hardest to do well, and they're the most important for your API's learnability. Daniela is a former teacher, and his talk is well worth a watch on the topic. Again, linked in the resources. We can also give our users less to learn. Back when I was doing lots of front-end work, I was installing things via npm, importing them using ES modules, packaging up my code with Webpack or Parcel. These are all pretty widely used tools and conventions in modern front-end development, or they were at the time. They've probably been supplanted 3 times since then. And then I'd use a Google library, sorry, Katie. And Google, well, they're in their own little world of front-end tooling. You can't just say import Google Maps. You have to load their script loader, tell the script loader what to load, give it a callback to tell you when it's done, and then the API itself is sitting in the global scope and you have to fish it out. I can't use the import keyword with Google APIs, but I also can't use my pre-existing knowledge. I have to figure out how to get all of this weird Google stuff to work with my tools. And their docs are like this too. There's these weird little Googleisms, unexpected details that you need to know in order to make their API work, hidden in some footnote far away from the docs for what you're actually trying to accomplish. Details that you might just know that if you work at Google, but this is a public API that's made for non-Googlers, so maybe you shouldn't have to know these things. And when we talk about all of this, it sounds an awful lot like we're talking about aesthetics. Code may not be particularly visual, but it's still something that we definitely have a sense of aesthetics about. Now, Sydney's Powerhouse Museum had an 8-year-long exhibit which unfortunately closed last week called Interface. And it has objects by Dieter Rams and Apple's Johnny Ive, and you can see this flow of inspiration, the shared values and priorities. You can also see in this exhibit a really interesting contrast. In the works of Rams and Ive, you can see this refined minimalist utilitarianism. Everything is deliberate and precise and quiet, and there's lots of muted whites and greys and silvers. It's all very serious and very German. And then next to that are typewriters and calculators made by Olivetti, mostly designed by Mario Bellini. I absolutely adored these things. There's lots of curved edges and round shapes. Kind of reminds me of my old Fiat 500. Lots of bold colors, bright yellows and reds. All very loud and fun and Italian, and there's 2 different families of design here. The Germans creating this utilitarian refined tool, and the Italians seeking to create an emotional reaction in the user of a calculator. And so it is with code. Different communities have different sets of shared ideas about what good code looks like, and we try to write idiomatic APIs, ones that fit in with the value system of the people using it and the code around it. And in Python, we talk about this so much, we have our own word for it, Pythonic. And that includes superficial things like using underscores instead of camel keys, but it also goes deeper. Chris's keynote this morning was about convention and construction, the 2 mechanisms that language designers use to shape how their languages are used. And we're kind of looking at the same thing from the other end, from the API designer perspective rather than the language designer. Python introduces these custom syntax elements for particular use cases, context managers, iterators, async and await. And when you're writing a Python API, you make it Pythonic by using those things. Why are my words going backwards? There we go, they're going forwards now. That's good. If you have a resource that opens and closes, make it a context manager. Don't expect your users to use try finally. If you have something that's conceptually a sequence, implement the iterator protocol. Make your API fit in with the aesthetics of its surroundings, the norms of the ecosystem that it's in. And those norms, they're learnability shortcuts. If your users can use the API the way they're accustomed to, they don't have to remember extra details about how your API works. At best, they can make your API intuitively discoverable. Everything works the way that your users expect without them having to look it up. And this is something that's really, really hard to do if you're not immersed in that ecosystem. You might end up with an API that violates your users' expectations in really subtle ways, like a staircase that has fewer stairs than you're expecting. You can't do it with a book or a checklist. You really have to be part of the ecosystem, interact with it, seek feedback and collaboration from others within it. So every ecosystem where your API is going to get used, there's these shared values and norms, and understanding them is key to understanding how the users of your API are going to feel when they use it. And the next thing I want to talk about is containing complexity. Computers are inherently unbelievably complex, and containing that complexity is basically our entire job as developers. When you're working with complexity on that level, it can be really difficult to build something that's unobtrusive, that gets out of the way and lets your users do their jobs. I used to do a lot of work involving content management systems and e-commerce platforms, and they all seem to fall into 2 different camps. Some set out to be simple. They have the 10% of features that 90% of users want. They were easy to set up, easy to use, and perfect so long as you were within that 90%. But if you want to make something slightly different, then you're out of luck. Others set out to do all things for all people. They've got heaps of tables, a checkbox for everything. They feel kind of enterprisey. You could do basically anything you wanted with them if you could figure out how to configure it. There's a Django-based CMS called Wagtail, which is really interesting because it's kind of the best of both worlds, and it achieves that using an interesting API. Most of these others, they give you a site out of the box, trying to make it so you don't have to write any Python to get started. But Wagtail's not like that. Wagtail assumed that you knew some Python and Django, and it made you do a little bit of coding to set up your page types. It had a few different places you could fit things, and it had a few pre-built things you could snap into those places. Or you could make your own when you needed to. The others were products that had an API, but Wagtail was an API. Wagtail's API design is kind of like Lego bricks. Instead of getting a website you can customize, you get all of the bits you need to assemble the website with comprehensive instructions and all the flexibility that you need to change things up if the instructions don't match exactly what you want. The other critical thing about Wagtail is that there's a few places you can snap your components. There's a handful of components that snap into those places, and the interface to those components are expected to provide are minimal and well documented. By using this snap-together architecture, but also using restraint with the number of moving parts, you can make an API that enables your users to build what they want rather than getting in the way. So this is one approach we can take to containing the complexity of our systems, one of the many ways to contain, abstract, and make them fit in your brain. But is it possible to go too far? We'll find out after the break, because I need a drink of water. Thank you for the one person that applauded me drinking water. I appreciate the reinforcement of staying hydrated. It's a very important thing to do. So before that happened, I asked, is it possible to go too far? And the answer is maybe. There are definitely APIs that go further than just simplification, APIs that try to construct a facade, that try to make it as if the thing that they encapsulate is something that it isn't. I'm going to talk about ORMs, object relational mappers, something that developer and speaker Benno Rice describes to me as constructively lying to you. When you use an ORM, you're interacting with your data as if it's a graph of objects that are all connected to each other. In reality, your data is sort of structured like that, as tuples within relations in a relational database linked by foreign keys. But when you query a relational database, it gives you this rectangular structure, and I've bumped there we go, with rows and columns, and you're usually getting your data from a different machine over a network. ORMs have to do a lot behind the scenes. When you make a query, they translate it into SQL. They get that rectangular result, they split it out, they make some objects and link them together, constructing this graph that they present to you as they go. They're laying down track ahead of the train like Grommet and trying to make it seem as though it was there all along, and they work. For simple cases, at low load, everything is fine. But that constructive lie is the root of a lot of sharp corners. More complex queries often end up being harder to write in an ORM than they are in SQL, and you need to understand the SQL that they generate, how that works, what the performance characteristics of that are, and you need to understand enough of the innards of the ORM to make it produce roughly the SQL that you want. The ORM lets you do complex queries, but it's rare that you can do it entirely at the ORM's abstraction level without thinking about the SQL underneath that it's going to generate. Then, once you've sent off that query, there's that illusion of the data being right there, which is a source of even more sharp corners. This, there we go, is a trap that's so common that it has its own name, the N+1 problem. What the ORM is lying to you about is that author isn't really there yet. When you access the author attribute, the ORM goes and fires off an entirely new request, doing a whole bunch of network I/O, constructs an author object out of the response, and just pretends it was there all along. You're hitting the network, and you're blocking on every iteration of this loop. The solution is to tell the ORM in advance what you're going to do with it. So you have this API that's lying to you to try to make it simpler, but to get acceptable performance, you have to break the illusion. You have to know about the lie. You have to know about the circumstances in which it's lying, and you have to code around it. And this same feature is one that has caused headaches down the road for the people building the library as well. With Python's async I/O syntax, you can only wait on I/O with an await keyword. So this model of the ORM might hit the network at surprising times doesn't really work. In his talk in PyConline 2020, Andrew Godwin revealed that the solution for this in Django is probably going to be that you just have to use select related. The code with the N+1 error that you saw before, when Django's in async mode, that just won't work. And this tells us that when we simplify, we need to tread with caution. Are we simplifying, or are we constructing a facade? How complex is it? How surprising is its behavior? And how is it tying our hands in the future? And to be clear, Django's ORM is very, very good. It's technically impressive and has a well-thought-out API, and it's just that it requires doing this deal with the devil, constructing this facade. To its credit, Django does let you pop the hood. It is pretty easy to provide custom SQL and still get all of the other niceties. And that's a good lesson to take away too. It may be constructing this facade, but at least it's being thorough about it. An object that's hastily made might look nice on the surfaces that you see or touch often, but look and feel rough everywhere else. You know how like everything you buy at Kmart is just like unpainted and nasty on the back? Like that. But similarly, a hastily designed API might have polish in its happy path, but when things go wrong or unexpected things happen, errors might be inscrutable or leak out from lower layers, or just be totally undocumented. The design of those parts of the experience is left up to chance. A thorough API will have error messages and documentation that tell you what's happening, why it's happening, and give you guidance on how to handle it. Rust is really good at this. When you hit a compile time error in Rust, the compiler has this lovely clean error message. It tells you where it found the error, what it was expecting, what it got instead. It gives you a hint for what it thinks you might have done wrong, and there's enough information here to figure out where to look next. Sometimes with Rust, there's enough information here to just fix the error by looking at the error message, which is kind of neat. React can't have big, long error messages because it's used on the web, so it needs to reduce its code size, so it uses numerical error codes. But it makes those error codes friendly by embedding them in a URL, so you get a clickable link in your debug console. When you click it, you get a nice error message, a description of what the error means, some common causes of that error, and advice on where to look, and links to other parts of the documentation to learn more. And this is a really neat approach that I really want to see more of. The other case where it really shows that an API is well thought through, where it shows the API is polished out the corner cases, is when that API enables you to polish out corner cases in your own work. Accessibility features tend to be less well-trodden paths, despite the large number of people collectively that rely on them. And if your API can make it easier for your users to build accessible software, more of them will actually do that, which is a win for your users and for theirs. So complexity is often inevitable in computing, and the best we can do is to contain and compartmentalize it. Having unobtrusive abstractions while being cautious around building facades that aren't honest, and thoroughly designing our edge cases and error paths, that can help contain that complexity. Now, this is the last of Ram's 10 principles, and it's a good place to close because it ties everything together. Good design is as little design as possible, definitely not as little work, but an end result that is minimal and focused. When I think about designing APIs like this, with as little design as possible, I like to think of it in terms of cognitive overhead, because nothing is infinite. The machines that run our software have limited resources, so we have to optimize how we use them. We try to write code that runs faster or uses less RAM or disk, or communicates less over the network or uses less battery. And we have a bunch of different tricks for that. If we can avoid doing something entirely, we will. We look for opportunities to use the same resource for more than one thing if we can. We might defer things to run later, or pre-compute them ahead of time, moving that work out of some critical period. Nothing is infinite. And that applies to developers too. There's a limited number of things we can remember, and there's an even more limited amount of things that we can keep in our working memory at any given time. And there's a limited number of hours in the day. And I don't know about you, but I'd much rather use more of that time doing stuff that's not work. It might seem kind of trite to say the human brain is just like a computer, but honestly, optimizing your API design for cognitive overhead is pretty similar to optimizing your code. The tricks are pretty similar, as is the sort of problem solving that we apply. You might try to use fewer concepts so that your users don't have to swap things in and out of working memory. You might design your API so you only have to think about certain concepts in certain places, so that they only have to hold those things in their working memory when they're working in those parts of the system. You might reuse concepts or patterns or the tools that you're building on top of, like languages and frameworks, tools and concepts that your users already know. And all of the ideas we've talked about today feed into this. Protocols, evolution, long-lasting technology create a shared language, and that aids learnability, creates this shared aesthetic that acts as a learning tool. Learnability, understandability go hand in hand with this principle. And containing complexity, doing that well, being unobtrusive, honest, and thorough, so that the complexity doesn't leak out, those are key components of how we achieve a minimal cognitive overhead, of how we make our designs as little design as possible. And honestly, it feels weird talking about APIs as being for people, and I think that's because we have this divide in how we think. We have the users, commoners who know nothing and need help understanding computing, and then we have the developers, the smarter, superior class, who know everything already. It feels weird because of contempt culture. We, developers, have a superiority complex, and so we think we don't need design. We think about the people that use our APIs and we go, oh, they're developers, they know computers, they don't need help, they already know this. Or perhaps we don't think about the people that use our APIs at all. Perhaps we just think as code as something we're building for the computer. But the thing is, unless you're directly fiddling with binaries in a hex editor, there's layers of abstraction between what you write and what the computer runs. Computers are dumb machines that are very good at doing simple things very fast. They don't need abstractions. The abstractions are for humans. The code we write is mostly for humans. My name is Leigh Brenecki. I'm not taking I'm not forming sentences properly, which is bad when you're presenting a talk. I'm also not taking I'm not taking questions on stage today, which is probably wise because I'm running out of the ability to speak properly. But I am available. I recovered from that one almost, on email and the socials, as well as in the hallway, grass. After this talk, if you would like to chat, I'd like to thank Lily Ryan and Benno Rice, who are really instrumental in getting past writer's block and finding the directions to take this talk in. And I also want to thank my employer, Octopus Energy, for flying me out here. We are hiring in Australia in Aotearoa, including here in Otatahi, so feel free to chat to me or one of the other octopodes around the conference if you're interested. Thank you.
Talk good.
Yee.
Question? Grass. Bye.